Have you ever answered a question with a group of people just to have everyone look at you because obviously that had been a question for someone else?
I was talking to Appa.
It gets even more complicated if someone is interpreting what is going on for someone else. And then a question gets asked and it's unclear if that question is for the person interpreting or the person you're interpreting for. Language can be very confusing even if multiple languages aren't being used at the same time. Layers of complexity are added when we get inflection, facial expressions, or body language from the person who you are trying to communicate with. Computers currently don't have the skill necessary to pick up on those layers of communication. And when you are writing a program, the computer is acting as a go-between or interpreter for you and whoever your end user will be. So how does the computer know when you're talking to it or when you're talking to the end user? Today, we'll dive into the data type of strings and see how it makes this problem easier for computers than we have it at a party. I'm Miss LaRose, and this is your lesson on strings. Hello, kiddos. As I was saying, language is the art of communicating complex ideas and information. Good communication skills help close the gap between the speaker and the listener, trying to make the possibility of misunderstanding as small as possible.
Get that out of my face.
It's not in your face, it's in my hand.
Get what's in your hand out of my face.
The biggest communication gap in programming is how to specify when you are talking to your program user or when you're talking to the computer. Programmers came up with a way to make this distinction perfectly clear, and that is through the use of a data type called strings. A string is just a piece of data that stores words, symbols, or other text that is surrounded by quotation marks. This makes it clear to the computer that the text being written is for the end user, not the computer itself. Meaning that if we put quotation marks around a line of code, the program will see that as a piece of data instead of as an instruction. The computer only has specific instructions that it is able to run. So if I try to just type into my computer, please write your name, my code is going to break because it will try to do what it's being told, but it doesn't see any instructions that it knows. If I want my user to know that they need to type their name, then I need to put quotation marks around it so that the computer knows it doesn't need to try and follow those instructions. Now, we have been introduced to one of the largest parts of programming. It is the process called debugging. A bug is when there is an error in your program, meaning something is happening to make your program not do the required task. Debugging is the process of removing those errors from your code so the program will run as needed. The problem with the missing quotation marks is called a syntax error. A syntax error is when your code is unable to run because the computer is unable to read part of the code. When we get a syntax error, the code will output a message letting you know that the code cannot be completed. It tells you what line of code it couldn't read and will give you its best attempt at explaining why it couldn't read it. To fix these errors, you need to go to that line of code, or sometimes the one before it, and fix what is wrong with the syntax of your code. Now, just because a string is written for your end user doesn't mean that your computer can't make changes to it. Since a large part of user interaction with code happens through string data types, programmers have created several ways to interact with the content of strings. In fact, you already did this in your first program for this class. The first program you wrote had you take in the name of a user by using an input, then concatenate that name with the word hello. Concatenation is just the joining of two strings together. This is done with the plus sign, and it will put the strings right next to each other. String methods are some of the most common ways that a computer can be instructed to interact with the content of a string. Methods are just pre-built bits of code designed to complete a task with a particular type of data. The computer is able to find out how long your string is, meaning how many characters it has, including spaces and punctuation, by using the length method. It can find specific words or values in your string by using the .find method, and you can change it to be lowercase or uppercase or to capitalize the first letter of the first word, and a whole slew of other things. I'm linking the W3 Schools page for string methods in the description below. It would be a good idea to take a look at that. One of the most important things that a computer will do to a string is to change it so that it's usable in the rest of your program. Changes you make to prevent your program from breaking because of a user input is called sanitization. When you put a bunch of methods on your input to clean up mistakes that your user might have made, like having weird capitals or adding extra spaces at the end or beginning of their input. Sanitization is just one part of what many programmers lovingly refer to as stupid proofing. Stupid proofing is the additional code that is written specifically for the purpose of preventing your program from being broken by careless users. Most stupid proofing works like baby proofing a house. You cover sharp corners, you block unsafe areas, and you make it so they can't open doors. Stupid proofing is like teaching someone how to ride a bike. You explain things over and over and over again, being as detailed as possible, and then you give them training wheels anyway. Sometimes you'll encounter logical errors in your code because your user didn't follow your instructions or misunderstood the instructions that you gave them, and sometimes it's because you didn't follow your activity diagram or pseudocode, or you didn't make them in the first place, and you forgot key steps in the process. Logic errors are when a mistake in the logic of your program causes your code to give a wrong output. A common example of a logic error is if you're trying to add two numbers that are saved as strings together. If I have my user give me two numbers in my program and then add them together, my code will just put them next to each other instead of doing the arithmetic. So if my user inputs 9 and 9, my output will be 99 instead of 18. To fix a logic error, you need to go back through your code step by step to make sure each needed part of the sequence is being completed. You will also want to check data types to make sure your computer can perform the correct steps with the data it is being given. For this program, I know that all user inputs are strings. So in order for the program to perform the arithmetic operation as I want, I need to convert both of my variables into integers. Logic errors are some of the hardest ones to fix because your code will run, but often the output will not make sense. While we're talking about debugging, let's cover our last type of error. A runtime error. A runtime error is an error that occurs while your code is running. This means there isn't a problem with the syntax of your code, and your logical steps seem to all be in place, but your code outputs a red error message. Some examples of when this could happen are when you're trying to use a variable that doesn't exist, or if you try to use a method on a data type that can't use it, or combine two data types that don't mesh, meaning you have asked the code to do something and it understands your instructions, but your instructions are impossible to do. Thank you very much for watching. As always, please let me know if you have questions, and I will see you all in class. Bye.